Come on in. Welcome to the forge. You can almost smell that coal fire, right? Hear the ring of the hammer? Today, we're going to pull a piece of history right out of the flames and uncover the real, secret difference between the two metals that built our world, iron and steel. You know, most people kind of use those words like they're the same thing, as if steel is just, a stronger, shinier version of iron. But that's not it at all. The real story is so much cooler, so much more revolutionary. It's not about just making something stronger. It's about a tiny, almost magical addition that changes everything. So to really get steel, you have to get its ancestor first. We got to start with pure iron. It's the foundation of this whole story. This strong, powerful, but ultimately flawed metal that literally defined an entire age of humanity. Iron, chemical symbol Fe, right off the periodic table from high school chemistry. It's a pure element. And for thousands of years, it was the toughest stuff we had. It gave us better plows, stronger swords, heavier anchors. But for all that raw strength, iron has a deep, hidden weakness built right into its crystals. Here's how I think about it at the anvil. Imagine iron's atoms are like a perfectly stacked wall of bricks. Now, that wall can hold up a massive amount of weight pushing down on it. That's what we call compressive strength. But if you hit it hard from the side, a sharp shock, those bricks just shear apart. The mortar holding them together is brittle, and the whole wall can shatter. So, how did the old smiths figure this out? They had no idea about chemistry, but through countless hours of trial and error and a whole lot of fire, they stumbled onto something that felt like alchemy. They found a secret ingredient that could completely transform the soul of the metal. And here's the real kicker. The secret ingredient that unlocks everything. It's not some huge amount of a complex new material. It's just a tiny bit of carbon. We're talking almost always less than 2% of the total weight. It's an unbelievably small key for such a massive, world-changing lock. That's right, this pinch of dust, this little whisper of an element, is the entire difference between a metal that shatters and a metal that can bend, that can flex, and that can spring right back, ready for more. It is the one thing that changes absolutely everything. And this is what brings us to steel. See, steel isn't a new element you dig out of a mine. Nope. Steel is born in the fire. It's the refined, perfected descendant of iron. So, the crucial point is this. Steel is not an element. It's an alloy, a mixture. At its heart, it's still like 98 or 99% iron, but it's been completely re-engineered at the atomic level by that tiny little bit of carbon. So let's go back to our brick wall for a second. Imagine those tiny little carbon atoms squeezing in between the big iron bricks. They act like a super strong, flexible, reinforced mortar, locking everything in place. So now, when that wall gets hit, it doesn't shatter. The force gets spread out, the wall gives a little, it flexes, and it holds. That new ability? That's resilience. And this right here, this just lays it all out perfectly. Iron, a pure element. Steel, an alloy. The core property of iron is that it's brittle. For steel, it's resilient. When you put them under stress, iron cracks and steel flexes. That is the fundamental difference that let us build the entire modern world. Okay, enough theory from the forge, right? Let's take this out into the real world. How does this difference between a brittle iron hand and a resilient steel spine actually play out in the things we use every single day? Think about an old cast iron hammer. Sure, it's heavy, it can hit hard, but if you miss your mark and hit the anvil at a weird angle, that shockwave has nowhere to go. The brittle iron can crack or even explode into dangerous shards of metal. Now let's take that same hammer, but forge it from steel. When you strike something, the steel head actually flexes on a microscopic level. It absorbs the energy from the impact and then springs right back into shape. You can use it 1,000 times, 10,000 times, and it just keeps its integrity. That's resilience in action. And this is where the scale just becomes mind-boggling. This quote really says it all. Yeah, the compressive strength of an iron beam is fine for a 2-story house. But to build a skyscraper that has to deal with wind, with vibrations, with incredible weight, you need a material that can flex and sway without failing. You need a steel spine. And you see this difference everywhere. Iron is fantastic for things where you just need heavy, rigid strength. Decorative gates, cast iron skillets that hold heat, heavy anchors. But steel is for the dynamic world. Skyscraper skeletons that have to sway in the wind, bridges that vibrate with traffic, tiny surgical tools that need to be strong but delicate, and of course, car frames designed to crumple to absorb impact and keep you safe. This simple secret, first figured out by blacksmiths thousands of years ago, didn't just stay in the forge. It ended up laying the foundation for the entire Industrial Revolution and pretty much everything that's come after. I mean, just look at humanity's journey with this metal. We have the Iron Age, which was a huge leap forward, but for almost 3,000 years, progress was pretty slow. Then, in the 1850s, we finally figured out how to make steel cheaply and in massive amounts. And in that moment, poof, the modern world became possible. And today we've got thousands of specialized steel alloys, each one perfectly tuned for some incredible purpose. So if you take just one thing away today, let it be this. Steel is not just stronger iron, it's a fundamental transformation. By adding less than 2% carbon, we didn't just make iron tougher, we gave it a new soul. A resilient one, capable of flexing, of enduring, of reaching for the sky. From the blacksmith's anvil, we got the skyscraper's beam. It really makes you wonder, doesn't it? What seemingly small discovery, what little secret ingredient are we mixing in our modern forges right now that's going to give birth to the defining material of the next age? Something to think about.